Welcome back to my channel Shri Statistics. So in my previous video I talked about the definition of partition of a matrix. So today we are going to study about how to determine the inverse by using that partitioning method that we talked about earlier. So suppose M is any square matrix of order n and it is partitioned as shown over here: alpha, beta, gamma and delta. Alpha, beta, gamma, delta. So where alpha is a submatrix of order say m cross m. If you would recall from my previous video, this was what I had mentioned, that when we partition these matrices, then suppose like alpha is m cross m, then beta will be of order m cross s, and then gamma will be of order s cross m, and delta is of the order s cross s. So like the total number, if suppose that the total number of rows and columns in this matrix is n, so here we are considering m first and then the remaining n minus m, which is being denoted by s, as second. So that is how we divide this portion. So suppose now that if m is partitioned in this way, then this inverse will also have to be partitioned accordingly. So suppose that we denote the inverse as a b c d as shown over here. So we know by definition that m into m inverse is equal to the identity. So on multiplying these we should get the identity. Now so consider these equations which will be formed. Like I have explained in my previous videos that how the matrix multiplication is done. This is multiplied by this plus this into this and like that. So solving this accordingly, the value over here is im. So here this portion is equal to I. Similarly, for the second equation, if you would check over here, this second equation will be equal to 0. So see here, this is set equal to 0. Then C is also set equal to 0, and the fourth part is set equal to I again. And so the determinant of delta should not be equal to 0, that is delta should be non-singular. So from equation 3 above over here, you can see that from equation 3 what are we getting? We are finding out the value of delta. So if we bring this gamma a to the right hand side, then the sign changes. Then we divide this by delta, so we are finding out the value of c over here. So to find c, after we find out this value of c from equation 1 and 5, this value is 5 and this over here is equation 1. So you can see over here that from 1 and 5 we substitute this value of c in equation 1, and then we calculate as has been shown over here that a is common, we take a common, and then from there we find out the value of a. Then from equation 4, this one is 4, we are basically doing the same thing again, that here we are finding out the value of d. So from 2 and equation 6, again we are putting this value of d in equation 2. So this is how we are, so now from here we have got b. So in that case you will notice that we have managed to obtain all the 4 values of this inverse. That is, m was our original matrix, and m inverse is our is this second matrix a b c d, and here we have found out a b c and d as shown in the derivation above. So this is how we basically use the partitioning to find inverse of matrices. Thank you for watching.